Okay, so today I'm gonna introduce to you Aqua's new programming language. It's called Amber, and show you how to set up programming environments in Linux with Geany. So first thing we're gonna do is open a terminal in our working directory, and we're just gonna clone Aqua Linux. Now, I've already got a video explaining how Aqua Linux's build script works, so you can go check that out before this video. And I'm going to set everything up quickly right now. So we're just going to run the build script with code amber and execute, and we'll see at the end that the file source/main.a was not found. That's because we haven't created our code file yet. Now it still is important that you run this first command, because this will set up the compiler and will generate some files that we'll need to activate stuff like syntax highlighting. So now I'm just going to go into Aqua Linux directory, go into the compiler, go into the langs directory, then go into the amber directory, and we'll see this file types.amber.conf file that was generated when we last ran the build.sh script. And we're just going to copy this and paste it in Geany's config directory. So on most Linux systems can be found at your home directory /.config/Geany. And so from there we're just going to go into the file diffs directory, and in there simply paste our file. And once we've done that, we can go back to our Aqua Linux directory. We can go back again and create a new folder. Now this will contain all the assets and the code, the source files that are necessary for our project. And so I'm just going to start off creating a main.a source file, which is the base of our whole application and program. And normally you should see that nothing is highlighted yet. Now that's because we need to go into the file types extension.conf file, which you can find in the Geany's user interface. And we just need to add the line amber equals star.a semicolon. Now this basically means that any file that has an extension with .a needs to be treated as an amber file, and so we can just reload, and now we should have syntax highlighting. Now if this still doesn't work for you, then you can go into document, set file type, and select amber file from the drop down, and so this will force this file to be highlighted using amber's syntax highlighting. Okay, now we can also see that the build commands were also set up by our file types.amber.conf file, and the only thing we need to do here is to copy the working directory, or the directory of your Aqua Linux installation, and you just need to copy that and paste it into the working directories of all the build commands. Now one thing to note is that you can't have any spaces in this directory path thing. I'm not exactly sure why, and so now we can click the brick icon, which will build our application and the KOS. This isn't necessary to be done each time, only when you update your KOS or your Aqua installation. What's more important is each time you make a change and you want to see that change here, you need to click the compile button, and then once it's compiled you can click the execute button, and this should execute your file. So now I just wrote a simple hello world script, which isn't very interesting, so I'm just going to write some graphical program quickly now so that I can show you a bit how Amber looks in general and how it runs. And so we can just create an events variable, allocate a bit of RAM for that. We can create a main loop, store the current events in our events variable. Now question mark events plus 64 is dereferencing the address at events plus 64, which is basically where the quit variable is. So this will check if the little cross button on the window has been clicked, and if that's the case we can break, and at the end we're going to just write exit 0 or return 0. In this case it doesn't really matter. And now I'm just gonna input some video commands. So video clear -1000. This will be red, and then video flip, and we can probably just put an FPS counter in there too. So I'm just going to store the video FPS in an FPS variable and print that out. And now if we execute this and we haven't compiled it, we can see that nothing happens. So we need to compile and execute this. And now we can see we have a nice red window with an FPS counter, and when we click the cross, it ends the program. That's just about it.